Alright guys, so there's videos on inequalities. You already done inequalities in Algebra 1, but like always we need to review it. Because in Algebra 2 we do more than just linear inequalities. We do absolute value, quadratic, and other crazy types of stuff. Okay? So we're going to review just basic inequalities. Because like always, we always got to go down to our basics. If you have a really good foundation, your basic, you pretty much can figure out anything else. So let's say we want x is greater than 5. Alright, so again, this is a single variable inequality. So since we only have one variable, we have to make a number line. So let's make a number line. So all I really want is just 3 numbers. And I want 0 to always be one of the numbers. Okay? What I usually do is I have the number that we have this is the inequality is set to, and also the opposite, so the negative number. Okay, so x is greater than 5, so we use a number line -5, 0 to 5, and x is greater than 5, so we're going to put our starting point at 5. Well, since it is less than, again, that means we do not include 5. We do not include 5, so that means it is an open circle on 5. Okay. Oops. Alright. So x is greater than. So now we want to know where all the values greater than 5 are at. Well, are they to the left or are they to the right? Hopefully you're shouting and screaming to the right. So you'll be correct. So boom. Look at that. You're done. Super simple. Alright, next is let's say we have the other one. X is less than or equal to -2. Okay, so once again we draw our number line. We have 0, -2, and 2. Okay, so our inequality is going to start or end at -2. -2 is less than or equal to. Since it has the or equal to part, it's going to be a full circle. So now it says x less than -2. Well, where are all the numbers less than -2? Well, they are all to the left. Look at that. There goes your answer. So one thing we're going to have to start getting used to is testing our number line or testing our inequality. So here's really simple to do. You just pick any number. So let's say we pick 0. Again, this is why I want you to always grab 0, because 0 is an easy number to check. So pick 0. Is 0 greater than 5? The answer is no. So it's right because the arrow does not go this way. X is less than -2. So let's pick 0. Is 0 less than -2? No. So we did this right because the arrow is not around, it's not going towards 0. Okay. So now let's step it up one notch. So now we're going to do it a one-step inequality. Okay, it's just like the ones we've been doing in warm-up, but even easier. So let's say we have x plus 2 is less than 5. So again, our main goal is always to get the variable by itself. In this case, our variable is x. So we want to get x by itself. Well, the first thing we need to get rid of is the 2. Like I always tell you, we need to do the opposite. So what is the opposite of plus 2? The opposite of plus 2, hopefully, again, you're screaming and shouting, is -2 or -2. So -2. What do you do to one side of the inequality? You do to the other of the inequality sign. So subtract 2 from both sides. So we have x is greater than 3. So now let's do our number line. So 0, 3, -3. Alright, so our inequality starts at 3. So it is less than, it's greater than. It does not have the or equal to part. So it is going to be an open circle. So now we says x is greater than 3. All numbers greater than 3 are this way. So now this is when we have to check. Once again, I always need for you to check. If you say, Mr. B, hey, is this answer right? I'm going to tell you, did you check your answer? Okay, you need to check your answer before you call me or Mr. Perlido to come check. You need to check it yourself. Alright, so let's check. We're going to use 0. We're going to use 0. So what we're going to do, we're going to plug in 0 to the equation. So we have 0 plus 2 is greater than 5. 0 plus 2 is 2. Now, is 2 greater than 5? You should be saying, no, Mr. B, 2 is not greater than 5. So this is false. This is false. So since it is false or incorrect, we do not shade this way. And did we shade on this direction? No. So we did it the right way. So now let's do another one. Let's do it in green. We have x minus 8 is less than or equal to 2. So again, we need to get x by itself. So we are going to add 8 to both sides. So we have x is less than or equal to 10. So now let's make our number line. So we have 0, negative 10, and 10. Our starting point is 10. So hopefully you're saying, oh, it has the or equal to. So we know it has to be a closed circle. Alright, x is less than or equal to 10. So less than, where are all the less than points going to? They're all going to the left. Okay, so that's it. So once again, we have to check. So again, let us check. We're going to use 0. So again, we're going to use 0. So let's plug in 0. We have 0 minus 8 is less than or equal to 2. 0 minus 8 is negative 8. Is negative 8 less than or equal to 2? This is true. Negative 8 is less than 2. So now, is 0 included in the area, or in the side we're going to? The answer is yes, right? The arrow goes to the left, and 0 is to the left, so it is correct. Okay. So now let's move on to two-step equations, just like we do for warm-up. Okay. So let's say we have, come on now, 5 minus 3x is less than or equal to negative 4. Alright. So we need to get rid of the 5. To get rid of the 5, we do minus 5 on both sides. 5 minus 5, they cancel out. You bring down the whole thing. So you bring down negative 3x is less than or equal to negative 4 minus 5 is negative 9. So I need you to pay attention right now. Make sure you are writing this on your notes. So take out your highlighters, your stickers, your glitter, whatever, to show that this is a really, really important step. Okay? So we need to get rid of the negative 3. Correct? So now we need to get rid of the negative 3. So in order for us to get rid of negative 3, we must divide. So we divide everything by negative 3. Now this is where it gets, as other kids say, tricky. So, whoa, my bad. Everything, we know these cancels out. Negative negatives cancel out, so this is going to be a 3. Now, anytime, so let me write this down for you. Some of y'all don't know how to spell. So, any time you multiply or divide by a negative, we must flip the inequality. Inequality. Okay, so we must flip the inequality. Anytime we multiply or divide, uh, we multiply or divide by a negative. So now our inequality was less than or equal to. So since we divided by -3, we must flip it. So now it becomes greater than or equal to 3. So now that's our answer. Like always, we're gonna graph it and then check. So 0, -3, and 3. So it's gonna be a closed circle at 3. So we're gonna check. So let's plug in 0 first. Let's plug in 0. Alright, so hold on, my bad. We draw our arrow. Arrow is to the right. So now let's plug in 0. So we plug in 0. We're gonna have 5 minus 3 times 0 is less than or equal to -4. Well, 3 times 0 is 0. So you have 5, because 5 minus 0 is 0. I mean, it's 5. So 5 is less than or equal to -4. Now, is this correct? Is 5 less than a -4? Is a positive ever less than a negative? No. This is false. This is incorrect. So, since this is false, it should not have the arrow going through it. The arrow does not go through it, so it means we did it right. Okay? If you did not flip the sign, you would have x less than 3. And then you would have the arrow going through it, and you would have known you would have messed up. So always check. If you ask me or Mr. Polito in class, hey, did I get it right? I'm going to ask you to show me your check numbers. Okay, so I want you to use 0. The only time you don't use 0 is when your starting point is at 0. Okay, I want you to use 0 because that is the easiest one to check. Okay, so we're always going to use 0 to check. Okay, so now let's do another one. So now we have 2x minus 7 is less than 1. So again, we need to get rid of the 7. So plus 7 plus 7. So we have 2x. These cancel out. Is less than 8. Divide by 2. Divide by 2. So we have 4. So now, are we going to flip the sign? Yes or no? Well, ask yourself the question. Did we multiply or did we divide by negative? The answer is no. We divided by 2. Not by -2. We divided just by 2. So the sign stays the same. Okay. So once again, we're going to do our number line. So 0, 4, then we do -4. So open circle. X is less than 4, so we're going to have it going this way. So now we always check. So again, we're going to use 0 to check. So we plug in 0. 2 times 0 is 0. So we have 0 minus 7 less than 1. -7 is less than 1. So now is this true? Is -7 less than 1? That is true. Since it is true, the arrow must be going through 0. Does the arrow go through the 0? Yes. So we did it correctly. So now let's do one that trips everybody out. I have no idea why. So let's do 8 is less than or equal to 2 minus x. Alright. So this trips everybody out for some reason because x is on the other side. It doesn't matter which way, where x is at. It don't matter, okay? So, once again, we need to get rid of the 2. So we do -2 minus 2. 8 minus 2 is 6. These cancel out, so you're left with -x. Now, how do you get rid of a negative? Well, you multiply by negative. So multiply by -1, multiply by -1. -1 times 6 is -6. Negative times negative is a positive. Now ask yourself this question. Did we multiply or did we divide by negative? You should say, yes, Mr. B, we multiplied by -1. So since we multiplied by negative, we need to switch our inequality. So now, a lot of people get this wrong because apparently they don't know that you can read left to right and right to left. So if you read it left to right, this says -6 is greater than x. If we read this right to left, this says x is less than -6. So you might be saying, whoa, that's crazy. Now let's look at it the elementary school way. Okay? Let's talk about the crocodile. The crocodile is eating the big number. It is hungry. The crocodile is eating the number 6. Now we reverse the order. Is the crocodile still eating the -6? Yes. It is still eating the -6. Okay? So it is still the same inequality. So now we can graph this. So again, 0, -6, and 6. So again, we do our open circle because it's less than. Now x is less than -6. So all my less than values are to the left. Once again, we need to check. So let's plug it in. Let's plug in 0. So we have 8 is less than 2 minus 0. 8 is less than 2. Is 8 less than 2 or is 2 greater than 8? The answer is no. So this is false. This is false. Since it is false, the arrow must not go through 0. Does the arrow go through 0? No. So we did it correctly. Okay? So now, this new step, the new stuff we're going to do now, this is the new stuff in Algebra 2. Okay? These are called compound inequalities. So this means that x is going to be in the middle. We have -3. So our real basic. -3 is less than x, which is less than 5. You're like, hold on up, this is crazy. We've never done this before. And I'm going to say, yes, you have. We've done this. Remember, this looks really familiar to our domain or ranges, right? We did this every time x was between a starting point and an end point. So we're going to do the exact same thing here. We're to graph this. Our beginning point is -3. And then 0 is here somewhere. And then our end point is 5. So this is an open circle. This is an open circle. So x is greater than 3, which is all the way. So x is greater than -3 is all these this way. X less than 5 is all of these here. But this is a compound, right? So we say it as x is greater than -3 and x is less than 5. So where do these lines meet or intersect? Where is x greater than -3 and less than -5? Well, the answer is going to be just in here. The only point where it's greater than -3 and less than 5 is between -3 and 5. So we're going to be just coloring in the in-between spots. But once again, we need to check. So again, we pick 0. Is 0 greater than -3? Yes. Is 0 less than 5? Yes. So that works out. So now let's do one with involving numbers. So let's say 1 is less than x plus 10, which is less than 11. So in order for us to solve the compound inequality, we must break it up into two inequalities. Okay? If you Google it, you might see other ways of doing it. I do not like it that way. One way is like they subtract 10 from all three sides, and that just gets confusing. So we are going to break this up into two inequalities. Into 1 is less than x plus 10, and x plus 10 is less than 11. Okay? So now we know how to do this stuff. So we subtract 10 from both sides. We get negative 9 is less than x. Subtract 10 from both sides. We get x is less than 1. So now let's graph. So alright, first let's rewrite this. So we have negative 9 is less than x, and x is less than 1. So this is our answer. Now let's graph it. So 0, negative 9, and 1. Open circle, open circle. So it's all these. So now once again, we always need to check. And yes, you're going to have to show your work on checking. So again, we're going to ask you, did you check it? Show me. Okay? So now, so let's plug in 0. 0 plus 10 is 10. So we have 1 is less than 10, which is less than 11. Is this true? The answer is yes. So, since 0 did make it true, we know 0 has to be in between the 2 points. 0 needs to be shaded in, and it is shaded in, so that it is correct. So now let's do one with x is negative. You'd be like, cool, because that sounds confusing. So let's say 2 is, oh, you're not working now, eraser? Alright, hold on. So we say 2 is less than or equal to 5 minus 2x, which is less than or equal to 7. So once again, we're going to break this up into two inequalities. And yes, I know I'm going to get a fraction, but whatever, don't cry. So we break it up into two inequalities. Alright. So we need to get rid of the 5. So we must subtract 5 and subtract 5. So these cancel, so you're left with negative 3 is less than or equal to negative 2. So now, minus 5, negative 2x is less than or equal to 2. Oops, my bad, I forgot my x. So now, divide both sides by negative 2. Divide by negative 2. Divide by negative 2. Well, negatives cancel, so this is left with 3 halves. We must flip the sign. Okay. Divide both sides by negative 2. So we have x, flip the sign. X is greater than or equal to 1. No, that one, negative 1, my bad. Negative 1. Alright. So now we have x is less than or equal to 3 halves, and x is greater than or equal to negative 1. Okay? So now let's plot this. Let's graph it over here. So again, 0, negative 1, and then 3 halves. So we know it's going to be here in the middle. So now let's plug in 0. since 0 is in the shaded area, we need to check it out. So let's check it. So we plug in 0. So 2 times 0 is 0. So we have 2 is less than or equal to 5, which is less than or equal to 7. Now is this correct? Is 2 greater than 2? I mean, it's 5 greater than 2 but less than 7. The answer is yes. So this is true. So this works out great. So it's good. Okay. So again, the key to this is always to check. Is to always check. Okay. When we get into more confusing ones like quadratic inequalities, absolute inequalities, we always need to check our points. So we're gonna do one more, and then you're gonna go do your 5-question assessment, and then get ready to do a lot of work in class. Because you know a lot of you are not good with simple algebra. So this is why we do a flipped classroom. You have 70 minutes to learn instead of me just talking for 40 minutes and you just having 20 minutes left to learn. So we're gonna do one more. So let's see. Let's say we have 4. So we have 4 is, oops, let's say negative 4. Negative 4 is less than x plus 4 divided by 2 greater than or equal to 0. Alright. So now we must solve for x. So this means we need to break it up into 2 functions, 2 inequalities. So we have negative 4 is less than x plus 4 over 2. Alright, so let's solve this one first. So again, we need to get rid of the denominator. So the best way to get rid of that is by multiplying by 2 on both sides. So we have negative 8 is less than x plus 4. Now, we did not flip the sign because we did not multiply or divide by a negative. So what that means is the negative 4 was already here, so we don't have to change anything. If we would have multiplied by negative 2, then yes, we would have changed it. But we multiplied by 2, so we don't change anything. So now we do minus 4, so that's negative 12 is less than x. So now let's do this one. We have x plus 4 over 2 is less than or equal to 0. Again, multiply both sides by 2. These cancel out. So you're left with x plus 4 is less than or equal to 0 times 2 is 0. Good job. Gold stars for everybody. So we have minus 4. So we have x is less than or equal to negative 4. So we have negative 12 is less than x, which is less than or equal to negative 4. We do our inequality, our line graph. Once again, we include 0. 0. Oops. This is negative 12, and then this is negative 4. So we know it's going to be here. But let's plug in 0 just to see if it's right. Okay, let's plug in 0. So let's plug in 0. So we get 0 plus 4 over 2. That's 4 over 2, which is 2. So negative 4 is less than 2, which is less than or equal to 0. Now, 2 is greater than negative 4, but it is not less than 0. So 0 makes it false. So 0 is not in here, so we know we did it partially right. So now pick another number that's in here. So let's pick a number in here. Let's pick negative 6. So negative 6 plus 4 divided by 2 is negative 2 over 2, which is negative 1. So we have negative 4 is less than negative 1, which is less than or equal to 0. Negative 1 is greater than negative 4, and it is also less than 0. So we did this correctly. Okay. So again, the reason why we did two checks was, one, just to make sure we at least shade it in the right part. So we know it should have not included 0, and it does not include 0. So now we pick another point inside the shaded area. We pick -6. Since the point inside the shaded area came out to be true, our stuff is true. Okay? So the assignment, you're going to have to turn it in person because I need you to do the line graph. Unless you take a picture of it and upload it to Edmodo, just go ahead and turn it in to me the next day in class. All right, see you then.